Hey, what is going on everyone? I'm Wicked, welcome back to Flutterly. In this tutorial I'm going to give you an in-depth introduction into another amazing open source package developed by Felix Angelov and the team at Very Good Ventures. It is called Mason, and I believe that due to its nature it's going to become really popular in the Dart/Flutter community soon enough. Therefore, I hope you'll enjoy this really in-depth explanation on Mason that will hopefully clear all your doubts about it. Without further ado, let's get right into it. Beforehand though, I want to send a token of appreciation to everyone supporting me as official YouTube members, especially to Diana and Michael aka Aza on Discord. If you want to become a member, all you have to do is to click the join button right next to my channel and pick your desired membership. Having that said, let's continue with our tutorial. Okay, so you might remember a while back I made a quick introductory video on the Very Good CLI, a package that was again developed by the team at VGV. Very Good CLI was all about generating a super powerful and efficient Flutter Starter application in just a couple of seconds. Now, if that video got you a little bit interested in how the Very Good CLI package managed to generate an entire project packed with features from scratch, then you must find out Mason is the answer to all of your questions. So, what is Mason? Mason is an open source tool that generates code from custom templates that are called bricks. Think of a brick as being a standalone component that you can reuse multiple times in the construction of your perhaps a new house. The constructors don't have to recreate the brick every time they need a new one for the foundation of your house. Similarly, developers don't need to recreate the same piece of repetitive code they've been doing in their last 10 to 15 projects. All they have to do is store the template of that code into a brick, generate the code, and reuse it in their projects as many times they would like. Now, don't think of a brick as being something static, unchangeable. Bricks can contain static text, however, most of the time you'll see them interpolating the text with dynamic variables. For example, let's say we have a brick containing the template for a short weather forecast. The text this template will generate is listed right now on the screen, and as you can see, there are these dynamic fields that will actually contain the data we'll populate our static text with, like temperature, condition, feels like, and so on and so forth. These fields are surrounded by what seems like a moustache, right? And that's because under the hood, Mason uses the moustache templating syntax in order to manage these dynamically interpolated fields. You can read more about how moustache works by checking out the link in the description. However, you'll learn mostly everything you need to know from this tutorial. So, having all of this in mind, you need to know that Mason can be used to generate any type of file containing any kind of text or code written in any of the available programming languages. This code can be generated from bricks of any size, ranging from a file containing few lines to hundreds of files and directories. Enough with the technical introduction. Let's get into some practical stuff, since this is how you'll be able to understand and learn Mason at its full potential. So, since Mason is an executable Dart package, meaning that it can be set to run globally right from inside the command line, we can install it by using the default Dart pub global activate Mason command. However, Mason wants to be a Dart independent tool, meaning that you won't need to have the Dart SDK installed on your computer in order to use it. Therefore, currently, you can also install Mason by using the Homebrew package manager on macOS. In the future, Felix mentioned that it will probably support Chocolatey and WinGet package managers on Windows platform, as well as the apt-get on Linux. In my case, I'm using Windows, so I'm currently stuck with having to use the Dart SDK in order to globally install Mason on my system. So, we'll open up a terminal and type in the Dart pub global activate Mason command. If you want to know more about the underlying process on how Dart exposes this Mason command globally to your terminal, I have a dedicated tutorial in my ongoing Dart from Novice to Expert complete course, and I strongly advise you to take a look at if you want to become a pro in Dart. So, after you successfully installed Mason, you should be able to access it easily inside your terminal by simply typing in Mason. As you can see, the Mason CLI popped right out. There are a whole bunch of available commands here, so in order for you to understand absolutely everything about the current version of Mason, I'll make sure to browse through and use every command by highlighting their purpose in detail. So, the first thing to have in mind is that Mason needs, as every Dart package, a root folder in which it will store all of its content, like configuration files, bricks, and templates. Having this said, you can initialize Mason in any folder you'd want to, whether it's a completely empty folder or an existing Dart or Flutter project folder you've been working on so far. At first, we're just going to create a new folder and initialize our simple weather forecast example. Later on this tutorial, we'll initialize Mason into an under development Flutter project. Right there, we're going to create a brick that will generate a page widget. So, first and foremost, let's create an empty folder called Mason_project and right away open it inside VS Code. Now, in order for the tool to work, right at the root of this folder, we need to have, at first, a configuration file called mason.yaml file. This file is similarly placed as the pub.spec.yaml file and contains mainly specific information about the bricks we might want to create. In our case, we need to write the weather brick as well as the path to it, which will be a folder called bricks and another subfolder called weather. What you also need to know is that you can mention already created bricks by using git, just like this. Just write the brick you want to import, the git URL, and the path to that specific brick. Now let's go right ahead and create our local folders. In order to create a brick, you'll firstly need a brick.yaml configuration file right at the root of your brick, which in our case is the weather folder. This brick.yaml file contains the name, which actually needs to be the same as the one we previously specified into the mason.yaml file, a short description on what this brick will actually generate, and as we'll see in a couple of moments, the dynamic variables will be able to interpolate within our text. One question remains though, and that is, where are we going to store our templates for the files and directories we'll generate from inside this weather brick? We're going to place them within a special folder named __brick__. Now, what you need to understand about this specific folder is that it is mainly a representation of how the structure of your futurely generated files and directories will look like. For example, if we create 3 folders here containing 3 files and another separate file, then when we run the generator command, Mason will output this exact same structure. This is actually where the very good CLI placed the entire Flutter Starter project structure before generation, right inside of this brick folder. In our case though, we just want to generate a folder called weather_forecast in which we'll simply include a weather.md file. The MD file stands for markdown so that we can easily see the moustache syntax for our dynamic fields. Inside, we'll write something like, hello, name, the weather for city is currently condition. There are temperature degrees, but it feels like. We'll then use a conditional field in which we'll keep track of whether there are any weather alerts issued for your location, and if there are, we'll display them properly by using the moustache syntax just as you can see on the screen right now. The variables prefixed by a pound denote sections. This means they can either be a list, populated or empty, or a boolean. This alert_issued field, for example, will be either true or false depending on whether there will be any alerts available for our location or not. On the other hand, the alerts variable will contain a list of alerts or perhaps an empty list if there aren't any. The variable prefixed by a caret denotes an inverted section. If, for example, our alerts_issued contains false, then the content between will render, and the same with an empty list. We could write here caret alert so that whenever there are no alerts, it displays you're lucky today. Now you can see we have various dynamic fields in this file that we want to generate. We must not forget that we need to let Mason know what are the brick's dynamic variables. So let's go ahead and write them down one by one into the brick.yaml file. If you feel like these configuration steps took a lot of time, you're right. Manually creating the folder, the files and the bricks for this job should definitely be an easier job to do. That's why if we create a new folder and we type in the mason init command inside of it, you'll see that it will automatically generate the same structure we previously created. Instead of manually creating all the folders and files, all you have to do now is to modify the files you need for your bricks. You can also create a new brick by typing the mason new command followed by the name of your new brick, and Mason will take care of everything for you. Now you might realize that if I had shown you just these commands at first, you wouldn't have understood the structure of a Mason folder in depth. So it's better that we learn the structure in the first place so that from now on we can use the CLI tools to facilitate the entire process. Coming back to our weather brick, we're done with writing its template. We have a weather brick that will generate a weather_forecast with a weather.amd file inside of it, based on some dynamic variables we'll have to input soon. So let's get to work. Power up a terminal in Mason's folder, and the first thing to do after you created a new brick is to run mason get. The mason new command I showed you earlier will automatically run the mason get command for you. This command will mainly get all the information it needs from the brick.yaml file and the path to the specific brick, and create a new .mason folder with a bricks.json file inside of it. This means that if we run mason list or mason ls, we'll be able to see all of our current initialized bricks. Inside of this bricks.json file, we'll find our weather brick and the path to it. This .mason folder should be excluded from source control as it contains local paths. So if you're planning to upload this to Git, make sure you add it to the gitignore file. Another thing to be noted about this .mason folder is that it represents the cache. If you take a closer look at the Mason CLI, you'll find out that there is a mason cache clear command. Well, if we run that, you'll notice the content from inside the .mason folder will be erased. And if we type in mason list again, you'll see our weather brick is not initialized anymore. So we'll have to run mason get one more time. It is finally time to get to the generating process for our weather brick. The command aiding this is the mason make command, followed by the name of the brick you want to generate the files and directories from. Let's observe what happens when we run the mason make weather command. You'll see that the CLI will prompt us to input the dynamic variables. So let's write them one by one. This round will say there is no weather alert for London. And we're done. If we take a look at the folder structure, you'll see that everything that was located inside our __brick__ folder got generated right to the root of our directory. This is the default outputting path. And if we open up the weather.amd file, we can observe our dynamic variables got substituted by our own inputs. Now you might question yourself that if you have multiple dynamic fields, it's not feasible to spend your time manually inputting them one by one in the terminal, right? So what can we do in this case? Well, we can write all of our fields inside a JSON file just like this. And this time, let's make sure we set up 2 weather alerts for London. Then we can go and type in mason make weather-c, which stands for -config, and the path to your JSON file. What we can also do is set up a preferred output folder so that it won't generate our folders into the root of our folder anymore. Instead, we'll also type in -o to set the output to a generated directory. If we hit enter, you'll see that all of our folders and files were correctly generated, this time in the generated/weather folder. Now, to make sure you understand how this works, let's try and create a new brick containing a main.dart file. Let's name it hello_world brick. As you might observe, Mason automatically created its folders and also added its path to the mason.yaml file. It also ran mason get, so that our new brick gets initialized and placed into the bricks.json file. So let's go right ahead inside our Hello World brick folder and set up our template for the main.dart file we'd want to generate. We can delete the hello.amd as it's just a sample file. So we'll create the main.dart file and type in a void main function printing a hello world line, appending a dynamic variable we can manually input before generating the brick template. Don't forget to place all of your dynamic fields into the corresponding brick.yaml file. Now all we can do is type in mason make hello_world -o and the path to the output folder, which in my case is going to be generated /hello_world. After it's done generating files, you can notice it successfully generated this file perfectly fine, where it was supposed to. What's great about this, since it is a .dart file containing a main function, is that we can actually run it from inside the terminal. So, as you can see, not only is Mason powerful as a generator tool, but it's also really independent and universal. I mean, you can literally go ahead and type in templates with files and directories in any other programming language. The possibilities are endless. However, now it's time to get into more advanced features of Mason. The thing is that currently our bricks are set up and registered as local bricks. What I mean by that is that if we go ahead into another folder and type in Mason make weather, it won't work, as the bricks we constructed are not globally available to our terminal. They are only available in our mason_project folder. What we can do in order to make them globally available is to type in the mason install command along with the -- source, path and the path to the brick. This will take the brick template at the specified path and put it into the home folder of your OS, right inside the mason/cache directory. This will then be accessible anywhere inside your terminal. In order to see how to use git paths also, let's globally install one of Felix's example bricks as well. We can do that by typing in mason install -- source git, the link to the GitHub page, -- path and the path to the specific brick. I choose the greeting brick from his repository. Now let's close all terminals and VS Code. To demonstrate that the weather and greeting bricks are globally accessible, we'll just open up a new Windows terminal, create a new directory called global and call mason make weather as well as mason make greeting. And as you can see that Mason will successfully generate the directories and files at the root of this folder. But maybe after some time we decide to remove one of these bricks since we won't use it anymore. How can we do that? Well, by simply calling the opposite mason uninstall command followed by the name of any global brick. It is time to move on and take a look at the very good CLI and how it was implemented using Mason. If we go to its repository and browse into lib source templates, you can actually notice that there is a file called very_good_core_bundle.dart. This is a file that was generated from their own internally developed very good core brick. It is called a bundle because it mainly contains every single file and directory template in a compressed manner. If you browse the entire file, you'll see by yourself that this file actually denotes the Flutter very good star project structure. So how was this bundle file generated from a brick? We can generate it too by using the mason bundle command. There are currently two types of bundles you can generate, an universal platform agnostic bundle and a Dart specific bundle. We can go into our original Mason folder and type in Mason bundle, the path to the brick, -t, Dart, -o and the path to the output. And if we hit enter and browse to that folder, we'll see that we have our own Dart bundle of our previously created weather brick. And I think this wraps up every command from inside the Mason CLI. I hope you understood the purpose of each and every one of them, and now it's time to practice everything we learned by integrating Mason into an existing Flutter project. What we actually want to do is to create a brick that will be able to generate a page widget. So let's go ahead and actually create a new sample very good project from the very good CLI. This is currently the Flutter app we're working on, right? Then we'd want to add Mason to it. Here's how I would do it to keep things organized and clean. First and foremost, I'd create a Mason folder at the root of our project. Then we'll go right again and open the VS Code terminal and make sure to navigate to the Mason folder. After we did that, it's time to call the Mason init command so that we'll get a fast generation of the folders we need as a starting point. We'll go right ahead and delete the default hello brick from the mason.yaml file and run mason get so that it will be erased from everywhere else. We also need to create our new page_widget brick by using the mason new page_widget command. Inside our brick, we need to write a template that will generate a completely functional Flutter widget with the following characteristics. It will either be a stateless or stateful widget, it will have a dynamic name and a dynamic container color, and you'll be able to choose whether you'd want to include a corresponding routing method or not. That will help you push the screen into the navigation stack further on. We'll start by creating the main file that will represent our universal page_widget. Now, an important concept to follow is how you should be naming your files. Since everything containing a moustache dynamic variable can be editable, names of the files are no exception. And we know that in Dart and Flutter, names of the files and directories should follow the snake case pattern, meaning that words should be in lowercase split in between with underscores. Mason comes with a bunch of naming patterns like camel case, constant case, dot case, header case, lowercase, Pascal case, and so on and so forth. You can Google them in order to see how each one of them works. What's more important is how you can use them. So, our file will contain a dynamic name, looking like this. However, you need to take into consideration that Windows does not allow the closing / tag on any file names or directories. If you're using VS Code though, this will end up fine if you write the above naming, since the editor will split them automatically like this, setting the /snakecase.dart as a separate file. But if you're using another editor that may not accept this, make sure you treat the / as a new directory or file, and it will work as it should. Let's get to coding the actual template of the widget. I know it's a little bit inconvenient or weird to look at this structure as a whole file, but for now, this is the only way we can bypass the / restriction. Now, at first, we'll have a dynamic field called stateful, containing either true or false, depending on whether the widget will be a stateless or a stateful one. So, we'll use the moustache syntax we previously talked about to tackle both of these cases and write the respective code for both implementations. We also need to make sure the naming of our widget class corresponds to the one written on the file, but this time it needs to follow a Pascal case pattern. So, for every part of our code that needs to have a dynamic name, we'll just write it this way. We'll proceed by adding the color dynamic field to both of our containers and the routable boolean value that will either place this piece of code or not in our scenario. Don't forget that each of these dynamic fields need to be set in the brick.yaml file. And we're actually done with templating our page widget. Now it's time to go ahead and generate a couple of page widgets by running the mason make command. We'll also specify the output in which we'd want those to be generated. In my case, I'll generate them into the lib/counter/view path since that makes sense to me. And as you can see, everything works as it should be. Every file is generated perfectly into the specified folder. We can actually go ahead and try them out by running our Flutter project and set them one by one as the home screen. And having this said, it's finally time to end this tutorial. I really hope that I cleared all your doubts about Mason. This package is currently in a development stage, so expect major changes and further amazing features in the future. What I heard is that the VGV team is working on hosting a platform just like the pub.dev where you could upload your bricks so that everyone can use them just like Dart and Flutter packages. That will be huge and I can't wait to see it in action. As always, if you like this tutorial, don't forget to smash that like button, subscribe to my channel and share the video with all of your friends and colleagues in pursuit of top tier development. Until next time, as always, take care, Wicked is out, bye bye.